Okay, this section 2-6 is on proving angles congruent. And when we prove angles congruent, we are going to use theorems. And what a theorem is a conjecture or statement that you can prove. And when you're doing this, when you prove them, you want to prove them true. And it's easy to do. So if you look here at our drawing, we have two lines that intersect. So we have angles 1, 2, 3, 4. Measure of angle 1 is 120 degrees. So if angle 1's 120 degrees, what would be the measure of angle 2? Hopefully you said because these are a linear pair, they're supplementary, so the angle 2 is going to be 60 degrees. Then if I look again, I have my two angles with 2 and 3. Again, they're a linear pair because they intersect the line and they're adjacent to each other. So 2 and 3 are supplementary, so if 2 is 60, angle 3 is, I'm trying to get you to think about this instead of just waiting for me to regurgitate the information. Okay, so now I have angles 3 and 4. What do you know about them? So what's the measure of angle 4? Again, they're supplementary, so if angle 3 is 120, angle 4 is 60 because they have to add up to 180. So now we know that angles 1 and 3 are 120 and measures 2 and 4 are 60. And if we look at our drawing again, angles 1 and 3 are called what? And angles 2 and 4 are the same thing. They are both vertical angles. And so our vertical angle theorem says just what you did here. Angles 1 and 3 have the same measure, and angle 2 and 4 have the same measure. So it's as simple as this vertical angle theorem says, vertical angles are congruent. And so we can say angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. When we do a proof, we did those in 2-5 a little bit because I wanted to start getting you ready for them. We talked about two-column proofs there. And with a two-column proof, we have our statements on the left, reasons on the right. You put down your first statement, it's always your given. Usually your second statement comes from that given. Sometimes you can do more than one thing from your first given statement, and you just keep going until you get down to what they asked you to prove. The second type of proof is a paragraph proof. Paragraph proof is written as sentences in a paragraph. So some people like to do their proofs in paragraph proof. Our standards do say that we have to do our proofs in several different forms. So let's start with proving another theorem before we go into actual two-column proofs. So in this one, measure of angle 3 is given to us as 160, and they say angle 1 is a supplement to it. So if I know that these two, angle 3 and angle 1, are supplementary, what is the measure of angle 1? Measure of angle 1 would be 20 degrees because they have to add up to 180. If angle 3 and angle 2 are supplementary, what's the measure of angle 2? You're already going, of course, it has to be 20. That's a silly question. All right, so now knowing that if angle 3 is supplementary to these two angles, what do we know about angle 1 and angle 2? They're 20. They're congruent. And that's our next theorem. So you just prove the next theorem that says congruent supplements theorem states if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So again, angle 3 was supplementary to the two angles 1 and 2, so angles 1 and 2 are congruent. There's also a congruent complements theorem. I kept wanting to say supplements. I knew that wasn't the right. So complementary angles are two angles that add up to 90 degrees. And so if you have two angles that are complements of the same angle or of congruent angles, then the two angles are congruent. So the same thing happens in complementary angles as it does in supplementaries. If we have two angles that are complements of the same angles, then the angles are congruent. Now we get into right angle theorems. Our right angles, you should know, by definition of right angle, that what measure does it have? It has 90 degrees, exactly. So, if you have two angles that are 90 degrees, what can you say about them? They are congruent. So all right angles are congruent. I know, silly, but that's the way it works. We just have to justify, and we're telling what we know as being true, and you know it. So, the second one that deals with right angles is if two angles are congruent and supplementary, then each is a right angle. So if two angles are congruent to each other that are supplements, the only value they can be is 90, because 180 divided by 2 is 90. So again, it's common sense, and we know it. All right, so let's go through a proof here. My first proof says that I am given an angle 1 is congruent to angle 3, and I have a drawing off to the right. 1, 2, 3, 4, 5, 6 angles are given to you, and I know angle 1 is congruent to angle 3, so I mark them as being congruent. What I'm asked to prove is that angle 6 is congruent to 4. So I'm talking about this angle here and this angle. So somehow I have to go from angle 1's congruent to angle 3 to get angle 6 in there and angle 4. So let's just start with our statements and reasons. And again, with our first one, we always write down what is given. And that was that angle 1 was congruent to angle 3, given. So now I have to look at my drawing, because this given, if I look in it, doesn't give me any more information. Sometimes the drawing will give you more from just this statement. So now I have to look further. So in my drawing, do I know anything about angle 1? Well, yeah. It's a vertical angle with angle 4. And I need angle 4. So I know angle 1 is congruent to angle 4 because vertical angles are congruent. Okay, so now I have angle 1 is congruent to angle 3, and angle 1 is congruent to angle 4. Then I know angle 3 is congruent to angle 4, and that's by transitive. Property of equality, of congruency. And so now I have angle 3 and 4. But I still am trying to get down to this angle 6 and angle 4. So if I look back at my drawing, oh wait, angle 3 is congruent to angle 6 because those are vertical angles. So I state vertical angles are congruent again. And now if I have angle 4 is congruent to angle 3 and 3 is congruent to 6, then angle 4 is congruent to 6, or angle 6 is congruent to 4. And then that is again by transitive. Property of congruency. So when you get down here to your proof, you don't write given with it. That only goes with your first statement. And you can then prove why that statement is true. So then we have a second problem. On this problem, it doesn't say you have to justify each step. But if I look here, I'm given angle X. This angle here has a measure of x plus 10. This angle is 5x plus 4y. And this angle has a measure of 4x minus 35 degrees. Since this one has an x and a y, I can't solve it because I don't know anything about it. But these two angles are just x, and I can look at my drawing and tell that they are vertical angles, and I know vertical angles are congruent. So since I'm talking about measures of angles, I put equal instead of congruent. So x plus 10 degrees equals 4x minus 35 degrees. Now I can start solving. I want to get x's on both sides, so subtract x. 10 equals 3x minus 35. So now I want the numbers on the same side, add 35. And that gives me 45 equals 3x. Divide both sides by 3, so division property of equality. Now I have x equals 3 goes into 4 once, remainder of 15, 3 goes into 15 5 times, so x equals 15. But now I'm not done because I can find the measure of this angle, which would be 25, so this angle is 25, but I have to find the measure, or the amount that y is. And I forgot to write down part of your information. It says find, or angle, this angle down here is 155 degrees, right? Because this is 25, and these two angles are supplementary, so that makes this angle 155. So now I can go 5x plus 4y equals 155 degrees. And I know x is 15. And so I take 15 times 5. After I substitute in, I better show that step. 5 times 5 is 25, so that's 75 plus 4y equals 155. Subtract the 75. So 155 minus 75 is 80. Divide by 4. Y equals 20. Now I found both x and y, and you may start your homework.